there's always a few students who prefer this method, the quadratic formula. And why do they prefer it? Because it always works. For me, it's a little extra work than I like to do, but we have to know how to use this because, as I shared with you in previous videos, the first method, the factoring method, will not always work. So let's look at this first equation. First thing I'm going to do is I'm going to set up what is my A, my B, and my C. So A is 12, B is -6, and C is 5. Now I'm going to press pause and I'm going to set up the equation. Alright, so I have added a calculator at the bottom of the screen to help us out. You can see I've dropped in where the B's go, the A's goes, and the C's. And so we have two negatives make a positive. I'm going to do all of this on a calculator in just a second, and it's all over 24. So into the calculator, and I have a very simple calculator over here, I can see, well, I know that -6 times -6 is 36. And then I need to figure out what is 4 times 12. That's 48, and 48 times 5. So let's see how this works. Very simple calculator. 4 times, oh, nope, it's only going to do that part. It's going to do very simple math. So I need to take, let me bring this back. Let me clear this whole thing. We have 4 times 12 times 5. Enter. And then I have 36 minus that number. 36. Subtract 240. Whoa, this is a problem. Let me show you why this is a problem. Let me press. Here's why this is a problem. So off to the side, you can see how I took 36 and then I combined that with a -4 times 12 times 5. I end up with -204. Here's why this is a problem. If you forgot this from 8th and 9th grade, this value inside, that's referred to as discriminant, always has to be, so this value always has to be greater than or equal to 0 if we have a real solution. Real solutions are numbers that you're used to seeing. They're numbers on a number line. Later on, we'll learn about what are called imaginary solutions that you would have been introduced to in Algebra 3-4, and they have eyes. But at this point, we're only working with real values. So you can see here, got a problem. The value inside, called the discriminant, is negative. What does that mean? There's going to be no real solution. Now, if you forgot from Algebra 1-2 or Algebra 3-4, what does that look like? Because a lot of you, like myself, need to connect to a picture. I've gone ahead and I set y equal to this. And so instead of setting equal to 0, in which I find the x-intercepts, called the zeros, when you set y equal to it, it's going to graph the quadratic function. So here is what we have. This is the picture of the function. And you can see it never crosses the x-axis. If it crosses the x-axis, that's what's going to define the solutions. So when we get these solutions that we've been achieving, they would be known as x-intercepts on a graph. Here we will have no solutions or no x-intercepts because the discriminant is negative. Let's look at example number 2. To speed things up, I'm going to go ahead and I'm going to take the numbers and input them in. Okay, so here we go. We have x equals, and remember it's -b, so negative with the 5 inside, and then it's going to be b squared minus 4ac, all divided by 2 times a. Okay, so I know that I end up with a -5 on the outside, and on the bottom I have a 24. Now I'm going to use a calculator, and I advise you to do the exact same. So I know that 5 times 5 is 25. Let's figure out what this is. So I have a -4 times a 12 times a -3. And I need to combine that with a 25. Let's combine that with a 25, and I get a -26. You know what? I think I must have plugged something in wrong. Let's try this again. So I should have a, oh, I bet you I hit the wrong button. There's a -4 times 12. I'm not used to using this very simple calculator, times -3. So I've just done this portion. This is a positive 144, and now I need to add to it the 25. So inside I have a positive 169. Let me come back here. This is a positive 169. Because the discriminant is a positive number, I know that I'm going to have two solutions. That's going back to 8th and 9th grade, and it's asking you to kind of recall that information. Now the square root of 169 is 13. Remember I spoke about earlier in a video how mathematicians do this so they only have to achieve the answer one time. So one time you're adding, the other time you're subtracting. And let me just jump over here and I'm going to show you. I took time to actually graph it, and you can see that I'm going to have two solutions. I'm going to have two solutions representing the two x-intercepts on a graph. So for this particular problem, -5 plus 13 is 9, so I have 9 over 24, and I could reduce that down to divided by 3 is 3, divided by 3 is, so positive 3/8 would be one solution, simplified. -5 and -13 is -18 over 24. Okay, I can divide both of these by 6, divided by 6, divided by 6, and -3/4. Those would be my two solutions, and I can easily see, once again, they are the solutions because when I graph them, they're the x-intercepts.